right?
Yeah.
Explain the importance and significance of semiconductors.
When you say electronics, what do you mean? You mean circuits, right? You mean digital circuits everywhere? You mean like any kind of small device that, like, when accelerated or given a potential, will do something extraordinarily out of its reach.
Yeah.
And so, but the circuit, when you see from the outside, it's well polished and it's like, it's just a metal.
Mm-hmm.
But the metal are just the contacts. I mean, the thing that makes it magical, or the thing that lets it do these magical things, are semiconductors. So it's like what's inside them is like a chip, a small chip, which is just like nanometers in size, nanometers or microns in size, which you can't see with the naked eye itself sometimes. I mean, you can see with the naked eye, but it's like you can't interpret those with the naked eyes. And these small chips, or these small junctions of small materials, you can say junctions of thin films, and when I mean thin, I mean in nanometers. These are the ones which have certain properties because they're not made of like common materials. They are made of non-abundant materials in the world, in our world, and that has some certain optical and electronic properties that can be used to, charge or activate these circuits. And hence, with some more logics, if you add into it, these circuits do what they do. And so it's like, since I told you that for me, it's like what happens behind everything, that's the curiosity, and that's why I took physics. And if I'm interested in electronic circuits, then I need to be interested in what's happening inside it and what's the basis of it. And the
Mm-hmm.
basis of electronics are semiconductors. And that's why I took it. And that's why I wanted to know more about it.
So these semiconductors are materials that have certain properties that aren't abundant in the world, right?
No, the semiconductors in itself are materials that aren't abundant, and then they have certain properties.
Okay.
So it's like, yeah.
So how so these semiconductors are extremely valuable, right?
Yeah, but it depends on the semiconductor too. Some are really abundant, like silicon is the semiconductor which we use for solar cells, and it's really abundant, but it also has like certain fantastic properties. But there are others who are like really non-existent. I mean, you have to like dig it into caves and find these materials. Like some are even radioactive, and then if you combine these materials, you get something really awesome. And that's why some circuits or some electronics are really costly because they have certain functionalities that depends on these semiconductors.
Okay.
And just finding these semiconductors is really hard. It's really a gruesome process.
So is there another avenue where we can invent these semiconductors based on elements on the periodic table?
That's where I come in. That's
Oh,
my
okay.
work. Okay, so it's like instead of just choosing one element or one material, my work is to combine two or three different elements and make a compound. So if you combine elements or materials, it's a compound. So I combine materials. I combine gallium, and you must know gallium from the table, from the
Yeah.
periodic table, and you know nitrogen, of course. So what I do is I combine gallium and nitrogen from the periodic table, and my work is to combine them, like develop a process to combine them, because people know, like even in your smartphones and all, for all the sensors that you use, the chip inside is gallium nitride. So it's like a combination of gallium and nitrogen. So
Okay.
for that, it's like the optical properties of gallium nitride is extremely valuable. And
Hmm.
and I am developing a process which is based on plasma to grow these films. Like I have gallium separately, I have nitrogen separately, and with a plasma process and with a reactor that I'm currently designing, I somehow am able to grow thin films which are like nanometers in size.
Wow.
And these thin films are gallium nitride. And if you combine, or if you like combine these films with silicon or like any other suitable material based on the application that you want to use, then it'll give you the output. So again, basically at the end, you just see like a black circuitry chip, but inside it is like gallium nitride. And I help to grow this gallium nitride. It's like I'm helping to develop a new process to grow this gallium nitride, which is like low cost and low. I mean, it's effective because right now to grow gallium nitride, people literally spend millions, and I have brought it down to 50K US dollars or euros.
Really?
I've built a reactor, which I mean, the cost of the reactor is 50K, but if you consider the miscellaneous and the logics apart, it must be like 70 or 80K, but it's still like 10 times less than what people use to grow gallium nitride. And with this, my work, my first year of my PhD was to develop this reactor and to grow, but now it's to optimize the material to achieve the highest quality that like market or industry comparable quality of gallium nitride I can get.
So when you say developed the reactor, what do you mean by that?
It means that I built it from scratch. So when I started my PhD, I mean, I opened my lab and there was an empty room. But it's like me with along with my supervisor, we designed a plan to like we bought equipments from the we first built a 3D model on how our reactor should be and what process are we using, and then we ordered the parts from companies. You know, there are a lot of plasma and vacuum based companies from which you can order the parts that you designed through either like SolidWorks, and you must be knowing SolidWorks.
What is it? Sonic Works?
SolidWorks. It's
Oh,
like a
Sonic.
AutoCAD models where you can build 3D models with like really good precision. So you build models, you go to companies and you say that you want these models for you and you want like physical parts for you, and they assess the model on how good it is and how feasible it is, and then they give you these parts, and then you assemble these parts, and then you build a reactor. And with this reactor, I mean, there is a physical process on how you grow the material in this reactor.
Mm.
And we study this process and we try to grow the material with the reactor. And I hope I'm not going too much into the physics side in here.